Hello, this is a video on dilution calculations. As you would know, because we've been alive and we drink Kool-Aid, dilution is all about keeping the solute the same and just adding solvent. And there are two names we give the solutions. Concentrated, which is before you add in more solvent, and dilute is which afterwards. Those two words are relative names, so there's no absolute numbers for those. So, and the rule with the dilution is that the moles of solute does not change. So, as you may or may not have watched videos for, if you have solutions, the way you find moles is molarity times volume, and the volume is in liters. So therefore, that's what the original equation is that molarity of the concentrated times times the volume of the concentrated is equal to molarity of the dilute times the volume of the dilute. Now, I don't like using that because that's not how we get our variable that we want on one side and variable on the other side. But what it does help us understand is, look, we talked about this already, that when your variables on the same side of the equal sign, they're inversely proportional, which makes sense. If your molarity, your parts per volume, is going up, then the volume you need to keep the same number of particles should be going down. So therefore, molarity and volume should be indirectly proportional, which that's why they're multiplied together. So therefore, if that's the case, these are the easier equations to use. If you want to know what the molarity of the concentrated solution, it's equal to the molarity of the dilute times the volume change. Well, as you know, if it's indirectly proportional, if MD is on the top, VD should be on the top. So VC is on the bottom. Okay? And if, again, this is the same, if you're looking for molarity of the dilute, it's equal to the molarity of the concentrated by the volume change. Again, molarity of the concentrated on top, volume of the concentrated on the top. And the same exact thing for when you're looking for volume. So these are actually easier equations to use than that one. I don't want you to use that one. These are in the right forms we want, which is we always want the equation in the form what we're looking for, and everybody else on the other side. So therefore, here we have a question, and it's asking you, how many liters of the concentrated sodium chloride solution do I have if the molarity of the concentrated solution is 3.12 molarity, and I dilute it, and then what I have is I have a solution that's 4.21 liters and 0.827 molarity. Now, one thing is, just like in most of chemistry, you may misunderstand the question to say the fact that you need to know how much more of the solvent you added. That's not true. It's two different conditions, like the gas laws. Okay, condition number 2, this is the dilute condition, and this, in the unknown, is the concentrated condition. So there is no addition going on. Most of the time in chemistry, we don't add those. We don't do addition. So therefore, you know that the volume, you're looking for the volume of the concentrated. You know what the molarity of the concentrated is because they tell you. You know the dilute volume, and you know the dilute concentration. So volume of the concentrated is equal to volume of the dilute times molarity of the dilute over the molarity of the concentrated. They're indirectly proportional, so they're on the top each. You plug in, you get 1.115 liters. So you need 1.15 liters, which rounds to 1.12 liters of concentrated solution at 3.12 molarity. So when you dilute it, it will become 4.21 liters at 0.827 0.27 molarity. And that's how you do all dilution questions. Thank you.